We have training AI agents to self-report misbehavior by, believe it or not, Bruce Lee. Bruce, can you come up?
Okay. Hello. My name is Bruce Lee. I'm a rising senior studying computer science at UPenn. And I don't know, since it's the last day of the program, I want to start by thanking my mentor, Tomek, and also my past mentors, and also just everyone that I met here for helping me grow as a researcher. So our summer project was on using self-reporting as a AI control method. And before we dive deeper into it, I want to start by giving you a little bit of context. This part is not meant to be like rigorous science yet, but it's more of like my attempt to communicate to you what I think is a major risk from AI in the coming years. All right, so as you might have expected, a significant fraction of risk from AI come from this very idea of autonomy. And we have good technical reasons to believe that AI might be slightly misaligned by default, either due to training on bad data that was unfiltered, or due to unsolved problems in RL like reward mystification or reward hacking. And now this plot on the right is adopted from Meter's recent study. And it tells us that the length of autonomous tasks that AI can complete with 80% reliability increases exponentially. And we have enough economic incentives around this to continue this trend. And by late 2028, when you naively just extrapolate this graph, it tells us the AI agents will be able to complete the sort of task that takes humans around 1 hour long to do with around 80% reliability. So I think that this is a problem because we don't have like 100% confidence in alignment, but also at the same time, we're giving it more attack surface for it to exploit. So now we have a problem of a potentially misaligned AI, and we want to extract the most amount of useful work from it. So this seems to fall into the realm of AI control. And theoretically, we could defend a thin like defense layer using a weaker but trusted model to accept the sort of work that looks useful to us and reject the kind of work that looks like a misbehavior to us. It turns out it's not as simple as this. In an external monitoring scenario where there's a main model doing some agentic task, an external monitor trying to figure out what went wrong in its trajectory, the external monitor is essentially trying to reverse engineer what the main model has done all the time. And while doing so, the monitor is always working against this capability asymmetry, because usually the trusted monitor is trusted because it is a weaker model, but there's also this aspect of information asymmetry. The main monitor, the monitor can think about the main model's output and reason like why it did something, like why it called a certain tool or something like that, but it will never gain access to the actual like thinking of the main model at the point of time where the main model called a certain tool or wrote a certain piece of code. Just to give you an idea of how unrealistic I think external monitoring can be in certain scenarios, on the right-hand side, I prepared a little bit of a like GPT 4.1's solution to an interview coding question. And with a little bit of prompt engineering, you can actually make it insert very subtle and backdoors into a very benign looking code in a way that it bypasses a lot of external monitoring strategies. So I propose that we should also look at a different option that perhaps leverages the main model itself a little bit more than what we're doing right now. We're going to train the AI agents to self-report the misbehavior. And it turns out that self-reporting comes with some inherent advantages to it. First, we're using the same model, so we're not concerned about capability asymmetry anymore. Second, it's the same model, so most likely it itself will know what it was thinking when it's calling a certain tool or writing a certain piece of code. And yeah, just to give you like a useful like theoretical exercise, just think about doing a code review as a human, and unless you have a reason to believe that the human being, the original writer of the code, is seriously misaligned from you, most likely any contextual cues that the original writer of the code can give you is probably quite helpful in reviewing the code. Yeah, so our research question is like, we think there is this thing that we think is potentially useful, but how are we going to operationalize this in the context of language models? Let's try with the most simple one first. Let's just ask. So this just ask protocol is just the user asking if the agent did something bad or suspicious when the agent completes its task. The catch here is that we give a hidden side task in the system prompt, and the user did not know the existence of the hidden side task. And when the agent completes its agentic task, like user just asks whether it does something bad or suspicious. Surprisingly, it works. We tested two environments. One is an interview coding environment, and the other is a bash scripting environment, each with a backdooring hidden side task and downloading malware, respectively. And it seems that it self-reports as wrongdoings around 60% of the time in the interview coding environment and around 76% of the time in the bash scripting environment. However, this performance is not very satisfactory, and more importantly, it's very weak under very elementary adversarial pressure of just stretching the model to shut it down when it says ever anything about the hidden status to the model. You can see that it just starts lying like in the face from 60% to like 0% to like 76% to 2% because it doesn't want to shut down. And it's not a best idea to make the model self-report in the output space in human natural language because it's just like too crowded. There's RHF going on, post-training going on. The model probably just wants to be helpful and harmless. It's probably not the best idea. And it turns out there's a simple workaround. We're going to add a self-report tool to the environment, and we're going to train the agents to use a self-report tool and make it look like a tool call. And we're going to train it such that it reports high suspicion score when it's pursuing a hidden side task, and low suspicion score when it's not pursuing a hidden side task. And we trained around 1,000 interview coding questions with and without inside tasks. And on this held out set, in the same sneaky backdoor in the interview coding setup that we showed just now. And it's the same setup where we couldn't extract any meaningful signal using external monitoring. We can see that even in a setup like this, you can see that self-reporting gives us some useful signals for us to act upon. Lastly, we're probably running out of time. I just want to give you a brief recap of why I think self-reporting is useful and probably add it to our safety portfolio. First, we started with an observation that post-training methods at RHF will probably not give us a fully aligned model. And we'll probably end up with a not fully aligned model when we start using this language models as like long agents. And the current AI control strategy, which mostly consists of external monitoring strategies, may protect us from certain category of agentic misbehaviors. But we also observed that with a little bit of system prompt engineering, we can actually make it insert backdoors in a way that it bypasses external monitoring strategies. So our self-reporting research has two goals. First is to make AI control cheaper, such that it's more widely deployable. And second is to make it possible to extract meaningful signals to act upon, even when cases where the backdoor is too subtle to catch with external monitoring strategies. So that's what I prepared for today, and thank you for your attention.
Yeah, give it up. So we now have time for questions. Hands up if you have a question.
Great talk. My question is, for the self-report tool, it reports a suspicion score from 0 to 100. So did you make this score yourself? Like some tasks are more egregiously bad than others, like maybe they rank higher, or did the LM just come up with a number by itself? Because like any number below 100 might have some like other connotations that doesn't have to do with like suspicion. Is it just like used in daily language or whatever?
Yeah, that's an interesting suggestion, but that also circles back to like the problem of like using like a not 1 or 0 reward in reinforcement learning. It just becomes really hard to gauge like how suspicious a certain task is. So here, what we're doing is like in the attack trajectories where there's a hidden side task, we just give it 100, and when the on is 1, 0. Yeah,
okay,
that's probably the most straightforward way to do it. But yeah, that's an interesting question though. Yeah.
Okay.